All right, everybody. This is for Engineering Chemistry 1335. I wanted to go through and make you a video that shows the correct answers for your exam that you just took. And so I'm going to go through this. I think that I'll probably be able to do this over the course of 2 videos. But first, I'm going to go ahead and do the video for exam 3.2. And so I'll zoom in just a second. I'm just going to highlight the answers. And go from there. So the first question is, how many electrons can be held in the 3p orbitals? Okay, so the 3p orbitals are those bow tie shaped orbitals about the x, y, and z planes. There's a total of 3 of them, and each orbital can hold 2 electrons. So the correct answer for this is 6b. Question number 2 is kind of a similar question. How many electrons can be held in a single orbital? Now, the important thing about that question is it doesn't say a p, an s, a d, or an f orbital. And so that I want you to treat that as kind of a clue that we're talking about one of these orbitals in a very general sense. So if it's an s orbital, that can hold 2 electrons. A p orbital, well, there's 3 of them, and each one can hold 2 electrons. So our correct answer for number 2 is A, 2. Number 3. What is the electron configuration of S, or sulfur? Now, sulfur on the periodic table, if you look at that, you will see that sulfur is, I'm going to share my screen on this one. Here we go. Sulfur has a total of 16 electrons. So you should use that. Sulfur is number 16 there. You can use that as kind of a clue for your potential answer. And what I mean by that is if you look at the exponents and add those up, 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 4 is 16. That's one way that you can approach that question. But also remember that you're filling up that S block, then the P block, then the S block, and then the P block again. But ultimately, our correct answer for this question is A, 1s2, 2s2, 2p6, 3s2, 3p4. Number 4, the electron configuration of 1s2, 2s2, 2p6 is true of all of the following except. Okay, so this is another question where you want to reference the periodic table. And when you reference the periodic table, you're looking for any species that has a total of 10 electrons. So when we look at the periodic table, what has 10 electrons? Well, F minus has 10 electrons. Neon has 10 electrons. Some of the other answer options were magnesium plus, okay, well, magnesium plus 1 has 11 electrons. Then oxygen 2 minus has 10 electrons, and sodium Na plus has 10 electrons. So our correct answer for our one that is not true, that would be C, magnesium plus. Question number 5. How many ways can a p orbital be positioned in 3D space? Well, that p orbital has an x, y, and z permutation, so the correct answer for that is C, 3. Question number 6. What is the molecular geometry of a molecule that has VSEPR notation of AX6? So this is a central atom, A, with a total of 6 adjacent atoms. It has no lone pairs of electrons, so that means that there's going to be 4 about the kind of 4 around the waist, and then 2 up top. 1 up top, 1 on bottom, sorry. 2 on the y-axis, the other 4 on the x-axis. And that is going to be octahedral. So that would make a shape that has 8 sides to it. Next up, question number 7. Which statement about bonding is true? A, covalent bonding is equal sharing of electrons. B, covalent bonding is unequal sharing of electrons. C, polar bonding or polar bonds occur when electrons are equally shared between 2 atoms. And D, all of the statements above are true. The correct answer here is A, covalent bonding is equal sharing of electrons. Remember, there's covalent, nonpolar, and then there's polar, and then there is ionic bonding. Number 8, what is the hybridization of the central atom in the molecule CH4, and what best classifies this molecule? Okay, CH4, that means a central atom, carbon, with 1, 2, 3, 4 hydrogen atoms off the center. So that would be, well, SPPP, sp3 hybridized. Okay, now an sp3 hybridized molecule, that is going to basically allow us, still sharing the exam. Okay, good. I was scared that I was sharing my periodic table, which wouldn't really be helpful. But here what we could do is we can effectively cancel out or cross out answers options A and B. So then we're left with C, D, and E. Well, A and B are out. E is out because that's not sp3 hybridized. And then we're really between a nonpolar molecule and a polar molecule. So when you think about a polar molecule, you should be thinking about things that have that game of tug of war. Well, here what we have is 4 different players, or 4 players in this game of tug of war, and they're all the exact same. So whatever force they're pulling with, they're going to cancel one another out. So C is our best answer for this. Question number 9. Which of the following molecules has sigma and pi bonds? Okay, so in order to answer this question, well, first of all, a sigma bond is basically your first bond. So the bond that exists between 2 atoms. A pi bond is a second bond. So if we're talking about something that has a double bond or a triple bond, then we're talking about something with both sigma and pi bonds. Now, as a contrast, CH4, that has single bonds only. So it has no pi bonds. But let's look at our answer options here. N2. If you draw that, what you'll learn is that N2 has a triple bond between the 2 nitrogens. Ethene. If you draw that, what you'll find out is that there's a double bond between each of our 2 carbon atoms. Carbon dioxide has 2 double bonds, and urea, H2CO, is going to have a double bond between the carbon and the oxygen. And it just dawned on me that our molecule is not urea, but instead it's formaldehyde. But H2CO, you're going to have a double bond between that carbon and that oxygen. So all of these compounds actually have both pi and sigma bonds. So our best answer for that is answer option E, all of the above. Now, question number 10. What type of bond is formed when an electron has been transferred from one atom to another? Okay, so transferred is basically the same way of saying, or you could say that a different way and say that it's effectively given up. So one atom gives away an electron to another. Now, if you give something away, are you sharing it? No, you're not. So answer option A, an ionic bond, is our correct answer. Question number 11. Which of the following molecules has a bent molecular geometry? So when we're talking about something with a bent molecular geometry, we are looking for water that has 2 lone pairs of electrons. So basically anything that has 2 lone pairs of electrons on the central atom, that would be a bent molecule. So B, water, is our correct answer. Question number 12. How many sigma and pi bonds are there in a molecule of ammonium? Okay, so if you draw this molecule out, you'll see that you have single bonds between nitrogen and hydrogen. You have no lone pairs of electrons on your nitrogen. You have a total of 4 sigma bonds. You have 0 pi bonds. Next up is question number 13. What is the hybridization of a molecule with the Vesper notation of AX3E? Okay, so we're talking about something that has a total of 4 things around it. So our approach to this should be SPPP. 4 things, X, 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 E. So this is a central atom that has 4 things surrounding it. So our correct answer is going to be SP3 for question number 13. Number 14, reads, which of the following molecules is a nonpolar or is nonpolar? So what we're looking for here is one atom that has the exact same thing around it and no lone pairs of electrons. CH3Cl, our central atom is carbon. We've got 3 hydrogens, 1 chlorine. That's going to be a polar molecule. H2O, 2 hydrogens, but then 2 lone pairs of electrons. So that's going to be a polar molecule. SF6. Okay, so here we've got a sulfur and 6 fluorine atoms surrounding it. So all of those fluorine atoms, those are all the exact same. That sulfur has no lone pairs of electrons. Question or answer option D, that nitrogen has 3 hydrogens, but it has a lone pair of electrons. So our answer for our nonpolar molecule is going to be SF6. Question number 15. In the Lewis dot structure of ammonium, sorry, that is ammonium, not ammonia. How many lone pairs of electrons are there on the central nitrogen? So ammonia has 1 lone pair of electrons. So that formula NH3, you'd add that up and you'd see that that's 1, 2, 3 hydrogens off the central atom and a lone pair of electrons coming off of that nitrogen as well. So answer option B1 is our correct answer. Question number 16. Which of the following elements has the greatest electronegativity? This is a question where we're simply looking at the periodic table and we're looking for, well, what's the substance that is in the upper rightmost corner of the periodic table? And so I'm going to switch to my periodic table here. We've got carbon, nitrogen, oxygen, and fluorine. And, well, fluorine is our most electronegative element. So it's in the upper right-hand corner. And that is actually going to be our correct answer for this one. So answer option D, fluorine, is the element with the greatest electronegativity. Now, question number 17. What is the total number of valence electrons in the Lewis dot structure for a chlorate ion? Okay, so for this, what you need to do is you need to account for each of the valence electrons that each of these different atoms brings in. And if you look at this, you'll see that there's an overall charge of -1. So that's 1 additional electron. So chlorine brings in 7 valence electrons. Each of our oxygens brings in 6. So 7 plus 6 plus 6 plus 6. 7 plus 6 is 13. Plus 6 is 19. Plus 6 is 25. And then we have to account for that negative. So our correct answer is D, 26. Now, number 18. Which of the following is not an example of a hydrogen bond? Okay, so a hydrogen bond, notice how all of these have OH. Okay, so that's one part of a hydrogen bond. But then we've got to have something else that's electronegative. And if you look at these, so we're looking for something that is not a hydrogen bond. So we want OH and then something else that's super electronegative. We've got nitrogen, bromine, fluorine, and oxygen. We know that fluorine is our most electronegative element. Oxygen and nitrogen are also fairly electronegative. So nitrogen, oxygen, and fluorine are generally indicators of a hydrogen bond is present. So answer option B is something that is not an electronegative element. Okay, question number 19. How many different positions can an f orbital have? Okay, so we have f orbitals. Okay, now if you think about this from the perspective of quantum numbers, an f orbital is going to be when your L value is equal to 3. So that means your M sub L value, the possible different positions could be +3, +2, +1, 0, -1, -2, -3. So there's a total of 7 different positions that an f orbital can have. So B, 7 is the correct answer. Now, how many electrons can an f orbital, or can all the different f orbitals hold? Well, there's 7 different positions. Each orbital can hold 2 electrons. So B, 14 is the correct answer. Number 21, what is the bond angle with a tetrahedral, or in a molecule, oopsies. What is the bond angle in a molecule with a tetrahedral molecular geometry? Okay, so a tetrahedral molecule, that's where we have 4 different things. So CH4 is a tetrahedral molecule. Is our bond angle? 109.5 degrees. Question number 22. What percentage S is a sp3 hybrid orbital? Well, it's got S, P, P, P. So 4 parts. One of those is S. So this is 25% S. Question number 23. Which wavelengths are the longest? Now, we're talking about our electromagnetic spectrum. And our longest wavelengths are going to be radio waves. Then we have, so we're going from radio waves to microwaves to infrared waves to visible, UV, and gamma rays. So our longest waves here are going to be microwaves. That's number 23. All right, well, that concludes the first part of this. I'll make another video where I go through exam 4.1 next. All right, hope this is helpful.